In this problem, we're treating a DNA molecule like a spring that is being compressed somewhat by the fact that there is a positive and negative charge on either end of the molecule. We can find the electrostatic force compressing this spring, this molecule, due to those charges using Coulomb's law. And Coulomb's law states that the electrostatic force between two charged particles is equal to the Coulomb constant K multiplied by the product of the electrostatic charges on the two particles divided by the square of the distance between them. In the case of this problem, we're told the molecule is singly ionized, which means that both charges have a magnitude of 1 elementary charge. They're only charged by the smallest degree by which they can be charged. So charge 1 is equal to 1 times the elementary charge, and charge 2 has the same value. So instead of writing out 1e times 1e, I'm just going to add a square to the 1e that's already there, and we divide by the square of the distance between them. Now from the information already given to us in the problem, we can already determine this force. We multiply, we sub in our values given to us in the problem. So K is equal to the Coulomb constant, which is equal to the value 8.99 times 10 to the power of 9, with units of Newton meter squared per Coulomb squared. The charge is equal to the elementary charge, which has a value of 1.6 times 10 to the power of negative 19, and this is squared, and we divide this by the square of the distance between the charges, which is just the same as the length of the molecule, given in the problem as 2.17 micrometers, or 2.17 times 10 to the power of negative 6 meters. And don't forget to square it. Put this into a calculator, and we find the force to be 4.89 times 10 to the power of negative 17 newtons. Now the problem tells us that because of this force, the molecule is being compressed by 1%. We can use this information to determine the exact length by which the molecule is being compressed. We can determine that displacement, which we'll call x. X is just going to be equal to 1% of the length of the molecule. So to multiply by a percent, say that's 0.01, which represents 1% of the length of the molecule. So that's 0.01 times 2.17 times 10 to the power of negative 6 meters, which gives us a length of 2.17 times 10 to the power of negative 8 meters. So now we have found both the force compressing the molecule and the distance by which it's been compressed. Using this information, we can relate these two variables together using Hooke's law. And Hooke's law states that the force that is compressing a spring-like object, the magnitude of that force, is equal to the spring constant of the object multiplied by x, multiplied by the distance by which that spring has been compressed. And since the problem is asking us to find that spring constant, we'll algebraically solve this equation for k by dividing both sides of the equation by x. So the spring constant is equal to the force divided by x. As we found earlier, that force has a magnitude of 4.89 multiplied by 10 to the power of negative 17 newtons. And the displacement has a value of 2.17 times 10 to the power of negative 8 meters. If we put this into a calculator, then we find the spring constant to have a value of 2.25 times 10 to the power of negative 9 newtons per meter. and that is the spring constant of this molecule. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I'll do my best to help you out as best I can. That's all for now, and I hope you all have a lovely day. Bye-bye.